But we're gonna, so just a little while ago before the second half started, so for people that weren't here, we did the distance between 2 points. And points are coordinates. And the subset number is just saying this is the first x, this is the second x. It's not like x squared or anything like that. So the distance formula for between 2 points is x1 minus x2 squared plus y1 minus y2 squared, and then you take the square root of the whole thing. Okay. So an example of that is if I had 2, 3, and hold on. All right. So if I had these 2 points and I wanted to find the distance between them, this is x1, y1, and this is x2, y2, and it doesn't matter. I could have called these x1, y1, and that x, as long as they're both a 1 and they're both a 2, it doesn't matter which is which. So I plug those into the formula. I have 2 minus 8 squared plus 3 minus 11 squared. So that gives me negative 6 squared plus negative 8 squared, which gives me 64 plus, 36 plus 64, which gives me the square root of 100, which equals 10. So the distance between these 2 points is 10 units. Okay. Is the length Okay, so we're looking for the shortest distance between a point and a line. So if I have a line, right, and I have some point, okay, I could draw any segment. I could draw a segment here, I could draw a segment here, I could draw a segment like way over here, but that's not going to tell me the distance between the point and the line. The distance between the point and the line is going to be the shortest segment that exists between the two, and that's going to be the one that falls perpendicular. So I'm actually going to be looking for this length. This is the distance I want to find. Okay, so we'll make the point really big. Okay, so we're looking for the length of a segment from the point to the line that goes perpendicular. Okay. Then we had the perpendicular postulate, which has come up before, but again, okay, this is a symbol for perpendicular. So if you're given a line and a point not on the line, so I've got some line here, and I've got some point here. There's only going to be one line between this point that'll go through this point and through this line. That's not perpendicular. That's perpendicular, but it's not through my point. There. So there's only going to be one line that goes between this point and through this line that'll be perpendicular. And that makes sense, right? If I draw any other line, it's not perpendicular. So that's why it's a postulate, because it makes sense. You don't have to prove it, right? Okay, line M contains points at -5, 3, and 4, -6. So first I'm going to go, okay, -5, 3, and 4, -6. And I'm going to draw the line because that's what I do. And through the magic of computers, I'm extending it. Okay. All right, so this is line M. Okay. Point P is at 2, 4. So I have this point out here hanging out, and I want to find this distance. Okay, so oh no, don't do that. What just happened? Okay. Trying to find the distance between this point and this line. And I want it to be perpendicular. That's not perpendicular.
Will it go straight through the corner of -2?
Yeah, it will. Okay, so I'm trying to find this distance here. Okay, but now I drew this and it drew nicely, and I can, but I don't actually know that this is 100% perpendicular unless I get out a protractor and I measure it and I make sure it's perfect and all that. So there's a way to find this line, to find out where it's going to hit the other line. Okay, so the first step we have to do is find the slope of M. Line M. Okay. Okay, so we've got our first step. We have to find the slope of line M. Now we have the points from line M, and our slope formula is y2 minus y1 over x2 minus x1. That's the formula to find slope. See, I shouldn't have used line M. I should have used a different letter. Let's do that. Let's change this letter from line M so it's not confusing with slope to, what letter would you like the line to be?
Q.
Q? Q's good, okay. Line Q contains these points, and so we're going to find the slope of line Q. Okay, so the slope of line Q uses the slope formula. So I can call this x1, y1, and I can call this x2, y2. So when I plug those in, I get -6 minus 3, and then 4 minus -5. Okay, minus a negative is a positive. So I get -9 over +9, which is -1. So the slope of line Q is -1. Okay, so that was step 1. Step 2 is we're going to find the equation of the line between P and Q. Okay, so we'll call this line Z? Z good? Okay, Z's good. We'll call that line Z. So we're going to find the equation of line Z. Okay. And we're short on space, so we're going to do this on the next page. Okay. So I'll give everybody a chance to write. All right, so we have that the slope of line Q is -1, and Q goes through these 2 points, and then P is over here at 2, 4. So our perpendicular slope is going to be positive 1. Again, because when we have perpendicular, we flip it and change the sign. This is x, this is y, so we're going to use this information to find the equation by plugging it into our favorite, y equals mx plus b. So I have 4 is equal to 1 times 2 plus b. So 4 is equal to 2 plus b. So b is 2. So the equation of z is y equals x plus 2. So after we have the two equations, we had to solve the system to find the point where they intersect. Okay, that's how we know for sure that this is the actual correct point. So we have our system. Our systems are y equals x plus 2. We need to find the line equation here. Well, we know the slope is negative 1. Our y-intercept is negative 2. Okay? So our second equation is y equals negative x minus 2. So far, so good? Okay, I can use substitution, or I can add these equations together and eliminate, which is probably the easiest because these x's are opposite, so they'll just go away. So if I add the two equations together, I get 2y equals 0, right? Because cancel, cancel. So if 2 y's are 0, how much is 1 y?
0.
0. Okay. I use this to find x. So 0 is equal to x plus 2. Subtract 2 from both sides. Negative 2 is equal to x. And so my point of intersection is negative 2, 0. Which is the point that we drew, but if we hadn't drawn it perfectly perpendicular and it hadn't, you know, if everything hadn't lined up quite well, we would have been, like, you remember that first line I drew was a little bit off? If I had just drawn that and then I thought that was the line, then what would the point have been? I would have found like some fractional point, you know?
It's
So
like midpoint next to the slope formula, basically. That's what I see in this.
no midpoint yet. Step 4, use the intersection and point P to find the distance. Okay, so if I call this x1, y1, this becomes x2, y2. I use my distance formula. And I plug everything in, and I get 2 minus negative 2 squared plus 4 minus 0 squared, which gives me 4 squared plus 4 squared, which is 16 plus 16, which is the square root of 32, which if I split that out, that is 2 times 16, and 16 is 4 times 4. So here's my perfect square. And the 2 gets left behind. So my answer is the distance between point P and line Q is 4 times the square root of 2. We don't actually have to draw a picture for this. Do you guys want to not draw the picture and just see what happens? Okay, so what we'll do is we'll say
We're just going to do it from the coordinates?
no picture. Actually, yeah, we'll just leave. Okay, so the slope of S, we're going to do x1, y1, x2, y2. So I've got 4 minus 2 over 5 minus 1, which gives me 2 over 4, which gives me 1/2. Questions about that one?
So the slope is 1/2.
The slope of line S. Now, we're looking for the perpendicular slope. So if I have 1/2, I have to flip it over and change the signs. So the perpendicular slope is going to be -2. And this will be the slope of line A, which would be the line that we're drawing through the point. Okay.
You said what is 1/2 what?
I'm sorry, what was the question?
I didn't get it when you said it's 1/2.
Oh, so if we have a slope of 1/2, the perpendicular, whatever slope you have, if you want to find the perpendicular, you flip it over and change the sign. So it's opposite and upside down. So 1/2 flipped over becomes 2, and it was positive, so now it's negative. Okay, so now that was step 1. Step 2 is we're going to find the equation for line A. So here's x, here's y, and here's m. So y equals mx plus b. So I've got 7 is equal to -2 times 1 plus b. So that's -2 plus b. Add 2 to both sides. So I get 9 is b. So the equation is y equals -2x plus 9. This is line A.
Is this slope intercept?
Huh?
What's B?
B is the y-intercept. Oh, we should draw the picture, otherwise we have to calculate the intercept. You guys want to draw the picture or calculate the intercept?
You calculated it.
We have to have the equation of line S
Okay.
to do the system of equations. So we can either draw it and find the y-intercept that way by looking at the picture, or we can calculate the y-intercept.
So we just found the y-intercept. Oh, for S.
This is for line A.
Yeah.
We need the y-intercept for line S because we have to find the equation for line S. So how do you want to do it? You want me to bring the picture back?
Or the picture on the test.
Yeah. Okay. Now this. Right back. All right, I've got 1, 2, and 5, 4. See what I mean about not drawing it quite right? Because see, now I don't know, is this line, is my intercept 1.5? So I'm going to go ahead and calculate it real quickly. So this is going to be 2a, and I'm going to calculate the equation of line S. Just because I don't trust my picture, because I reduced that graph, so I don't know that it's quite. I have an x and a y, so I'm going to use those. Oops. So I'm going to say 4 is equal to 1/2 of 5 plus b. Yeah, it's going to be 1.5. Four is 8/2. If I subtract 5/2 from 8/2, I get 3/2, or 1.5. So it is drawn correctly. It is 1.5. So, so my equation for line S is y is equal to, was it negative? No, it's positive 1/2. 1/2 x plus 1.5. And line A is y is equal to -2x plus 9. Okay. So I have to find the point of intersection. So I can either do substitution or I can do elimination with multiplication. Do you guys remember any of those? Okay, well these are both y, right? So y is the same thing as y, yes? So I can say that these two are the same as each other. There's an x in there. Like that. And solve it that way. Or I can multiply this top equation by something that would make this a positive 2 and cancel them out. Which do you think is the way to go?
Positive 2 and cancel them out.
I've got one vote for that.
I agree.
Okay, so we'll get rid of this then. Okay, I need to turn a 1/2 into a positive 2. What do I multiply it by? 4. So I have to multiply this whole thing times 4. Okay, so that means 4 times y, 4 times 1/2 x, 4 times 1.5. And what I get is a new system that says 4y is equal to 2x plus 6. And y is equal to negative 2x plus 9. I'm going to add those together. And I get 5y equals 15 because the x's will cancel out. So y equals 3. And then I use this y to solve one of these to find x. Which one do you want to use? The 1/2 and the 1.5 or the negative 2 and the 9?
Negative 2.
Really? I'm so surprised.
No, that's a little-
I was kidding. I'm not at all surprised. Okay, so I'm going to subtract the 9. And I'm going to get negative 6 is equal to negative 2x. If I divide by negative 2,
True.
x equals 3. So my point is 3, 3. And then my last step is to find the distance. Using this point of intersection and point P, which was 1, 7. Okay. So 3 minus 1 squared plus 3 minus 7 squared, which gives me 2 squared plus negative 4 squared, which is 4 plus 16, which is the square root of 20. And 20, I'm going to put this up here, is 2 times 10, which is 2 times 5. So I have a pair of 2's, so those can come out, and that 5 gets left behind. So 20 is going to be 2 times the square root of 5.
It's like a little R10.